Why is underscore underscore init underscore underscore always called after underscore underscore new underscore underscore? I'm just trying to streamline one of my classes and have introduced some functionality in the same style as the flyweight design pattern. However, I'm a bit confused as to why underscore underscore init underscore underscore is always called after underscore underscore new underscore underscore. I wasn't expecting this. Can anyone tell me why this is happening and how I can implement this functionality otherwise? Apart from putting the implementation into the underscore underscore new underscore underscore, which feels quite hacky. Here's an example. Outputs. Why?
Underscore underscore new underscore underscore is static class method, while underscore underscore init underscore underscore is instance method. Underscore underscore new underscore underscore has to create the instance first, so underscore underscore init underscore underscore can initialize it. Note that underscore underscore init underscore underscore takes self as parameter. Until you create instance, there is no self. Now, I gather that you're trying to implement singleton pattern in Python. There are a few ways to do that. Also, as of Python 2.6, you can use class decorators.
Use underscore underscore new underscore underscore when you need to control the creation of a new instance. Use underscore underscore init underscore underscore when you need to control initialization of a new instance. Underscore underscore new underscore underscore is the first step of instance creation. It's called first and is responsible for returning a new instance of your class. In contrast, underscore underscore init underscore underscore doesn't return anything. It's only responsible for initializing the instance after it's been created. In general, you shouldn't need to override underscore underscore new underscore underscore unless you're subclassing an immutable type like str, int, Unicode, or tuple. From April 2008 post, when to use underscore underscore new underscore underscore versus underscore underscore init underscore underscore on mail.python.org. You should consider that what you are trying to do is usually done with a factory, and that's the best way to do it. Using underscore underscore new underscore underscore is not a good clean solution, so please consider the usage of a factory. Here's a good example, active state f recipe.
To quote the documentation, typical implementations create a new instance of the class by invoking the superclasses underscore underscore new underscore underscore method using super current class cls dot underscore underscore new underscore underscore cls with appropriate arguments, and then modifying the newly created instance as necessary before returning it. If underscore underscore new underscore underscore does not return an instance of cls, then the new instance's underscore underscore init underscore underscore method will not be invoked. Underscore underscore new underscore underscore is intended mainly to allow subclasses of immutable types like int, str, or tuple to customize instance creation.
In most well-known O languages, an expression like SumClass, arg1, arg2, will allocate a new instance, initialize the instance's attributes, and then return it. In most well-known O languages, the initialize the instance's attributes part can be customized for each class by defining a constructor, which is basically just a block of code that operates on the new instance, using the arguments provided to the constructor expression, to set up whatever initial conditions are desired. In Python, this corresponds to the class underscore underscore init underscore underscore method. Python's underscore underscore new underscore underscore is nothing more and nothing less than similar per class customization of the allocate a new instance part. This of course allows you to do unusual things such as returning an existing instance rather than allocating a new one. So in Python, we shouldn't really think of this part as necessarily involving allocation. All that we require is that underscore underscore new underscore underscore comes up with a suitable instance from somewhere. But it's still only half of the job, and there's no way for the Python system to know that sometimes you want to run the other half of the job, underscore underscore init underscore underscore, afterwards, and sometimes you don't. If you want that behavior, you have to say so explicitly. Often, you can refactor so you only need underscore underscore new underscore underscore, or so you don't need underscore underscore new underscore underscore, or so that underscore underscore init underscore underscore behaves differently on an already initialized object. But if you really want to, Python does actually allow you to redefine the job, so that some class, arg1, arg2, doesn't necessarily call underscore underscore new underscore underscore followed by underscore underscore init underscore underscore. To do this, you need to create a meta class, and define its underscore underscore call underscore underscore method. A meta class is just the class of a class. And a class underscore underscore call underscore underscore method controls what happens when you call instances of the class. So a meta class underscore underscore call underscore underscore method controls what happens when you call a class, i.e. it allows you to redefine the instance creation mechanism from start to finish. This is the level at which you can most elegantly implement a completely non-standard instance creation process such as the singleton pattern. In fact, with less than 10 lines of code you can implement a singleton metaclass that then doesn't even require you to futz with underscore underscore new underscore underscore at all, and can turn any otherwise normal class into a singleton by simply adding underscore underscore metaclass underscore underscore equals singleton. However, this is probably deeper magic than is really warranted for this situation.
If you want to support the channel, please consider liking and subscribing.